So I'm here to talk to you about establishing a measurement framework, and that's a very fancy name to explain that this is about how we make a transition of translating our research design into data and into fieldwork. You're already familiar with the slide probably more than I am, so I am not going to go over all the different parts of the work that you're going to talk through today. I want to focus on the topics of this session, and I'm going to divide it into three separate takeaways that are how you actually will interact with this in your day-to-day as a field coordinator. So the first thing that's important for the whole research team is to make sure that everyone understands how to communicate about the project. So when we talk about research design, it then is implemented through a series of data collections and a series of indicators, a series of data sets that we'll analyze. So the first thing that we need to do is to make sure that we have a way to talk about this that everyone understands. So when we talk about a data set, we know everyone in the team understands which data sets we are talking about, and everyone understands what are the different steps that we're going to go throughout the project's life cycle to get to finally analyze the impact of a project. The second thing is how different research designs affect what you are doing in the field. So what are the field activities that are really important and are key to making sure that our research design is the correct way to measure the effect of a project? And finally, we're going to talk a little bit about randomization, which, as we all know, is key to ensuring that we have comparable groups in randomized control trials. So whenever we're talking about experiments, this is important, but it's also important when we're talking about survey and data collection and how we're sampling our population of interest. So let's get started and talk about how we communicate about data. You know, when we're working in a small team, for example, we're at school when we're writing our thesis, it's mostly us and we are dealing with our own data and we have a very good understanding of how things work. But here in DIME, you will often, and also where I am now at DIL, we have projects that will last 5, maybe 10 years, and a lot of people will come and go. So it's important to make sure that there is a shared understanding and a simple way to communicate different aspects of the project, especially when it comes to the data work, because that's most commonly what gets handed over from one person to the next. So to make sure that we have a plan on how to communicate about this, DIME Analytics has designed what we call a data map, which consists of 3 different components to communicate and plan data work. So we're going to go through each of these, but just so you have a full list, we're going to talk about data linkage tables, which is basically a list of all the data sets that we will use in our project and how they connect to one another. We're going to talk about a reference data set, which is the authoritative lists of all units of observation that we encounter throughout a project. And we're going to quickly talk about a data flow chart, which is just a way to plan how we get from the original data that we acquire to the final analysis data set. I'm going to talk about each of these components in detail, but I want to stress here that it's important to create a data map as soon as you start thinking about your project to make sure that you don't get any hiccups in the process. And it's fine to update this data map as you go, but it will really help you visualize your entire data work process and the different field activities that are involved in constructing the analysis data. So let's talk about what I'm calling rebranding a reference data set. So this may be a little bit small for you, but basically this is a list of a lot of different people, and we have their household IDs, their community IDs, first name, last name, age, and then we have a few different columns that say things like, are they in our sample? Are they treated? Did they attend training? So basically what this is doing is two things. One, it's a data set that includes all individuals that we ever observed in one unit of observation that is in our data. In this case, it's the farmer. And we could have one for, let's say, all the students that ever appeared in our project, all the schools that ever appeared in our project, all the teachers that ever appeared in a project. And what we're doing next here, so we have a way to identify all of these individuals, and then we have what we call research variables. So research variables are things that are part of the research design that are not necessarily observed. It's not measurements that we're doing during a survey or during some sort of observation. Basically, it's things that we have decided on, like treatment assignment or sampling. So this is the authoritative source for all of these things. And the reason why we have this is that throughout a project's lifetime, we will be acquiring more and more data, and we want to make sure that we are not duplicating people or other units of observation in our data, and that we are considering the correct values for our research design variables for them. So let's say, for example, that all of my examples are always from ag, because that's from agriculture projects, because that's what I used to work on when I was here at Time. So we're going to start with, we have a farmer's listing. And we do a farmer's listing at baseline before we implement a project. And then we go around the village and we ask the names of all of the farmers and what their plots are. And then we have a list of everyone that's in there. And then after the project is implemented and over, we go back and we need to interview these people again. And then we have another listing. We cannot ask people, hi, what was the project ID that we used for you in our data set during the baseline? Because they will not know that. And we're trying to avoid collecting extra confidential information like their national IDs. And in many cases, people will not have that, but we're also trying not to collect extra identifying data that will not be used for analysis. So what we're going to do is that we're going to ask their names again, and maybe they will use slightly different names, right? And then, let me see if I have an example of this here. And then I'm going to compare those names to the names that I had originally. If I listed everyone that was observed, even if they were not directly surveyed during baseline, I will be able to see if new people that I see now are the same people that I interviewed before with a slightly modified name, or if there's someone that I actually did not interview at baseline, but who was already living in my village. So it's a way for us to keep track of everyone that we have in our population, or it's the closest that we get to a census of our population of interest. So whenever we have new data, we will combine that data with a reference data set to find the project identifiers for those new observations, and we will use that to also, if these people were not previously in our sample, to create new identifiers for them. So basically, this is the plan to make sure that we have a consistent unit of observation, and it consists of identifying a variable, and we'll talk in one slide about why identifying variables are important. So basically, it's important to know about your context and have a plan for things like, is there a name that is commonly used in a village or across a culture? I know that there are some countries where, well, the first son is always named one thing, and then the second son is always named another name. So we want to have a plan to address this, and usually the reference data set is a way to track it. Next, we have a data linkage table. What the data linkage table is doing is that we are listing all of the original data sets that we will receive. So, for example, if I'm doing a baseline survey and an endline survey and I'm receiving administrative data, I'm going to list all of these data sources in this data linkage table. And what we usually want to do in the end with all of these different data sets is that we want to be able to combine them to create a panel data set where you can track people over time, or to combine different measurements that come from different sources into one analysis data set. And this is where the ID variables play a key role, because we'll use these identifying variables to connect different original data sets. So what a data linkage table does is that it has metadata about all of the different data sets that are included in the project, and we list key important things about these data sets, such as what is the nickname or the short name that we'll use to refer it on our day-to-day emails and meetings, but what is the unit of observation that we see in these data sets, how often they are collected, how we can combine them, and what are the key information in each of these data sets. So the way we get to this table from a research design is that we are going to start listing all the key concepts that we have in our project. And this is, again, going back to the agriculture example, we may be interested, for example, in seeing how irrigation makes farmers more resilient to climate shocks. So that's the big picture of our research question. But how does that translate into data? Well, we want to measure things like farmer productivity, their income, and climate shocks, and use of irrigation. So those are the concepts that we're thinking about. How do we then observe or measure these concepts in the field? Well, we'll typically measure farmer productivity as yields. That means the amount that was harvested per area cultivated. So we need to go and measure the weight of the harvest and the cultivated area. We want to talk about climate shocks. How do we measure climate shocks? We want to track things like temperature and rainfall. Then we need to think, how do we observe these different measurements? Well, when I'm measuring quantity, at what level do I quantity harvested? What do I need to observe? I need to think about each plot that was cultivated and how much area was cultivated in that plot and how much crop was harvested in there. Similarly for temperature and rainfall. How are temperature and rainfall measured? Well, you can measure temperature very locally. Maybe you'll only have county-wide data, or it would depend on your context, but you need to think about how you're going to observe this and how you're going to connect this to the rest of the data that is in your data set. And finally, well, not finally, we have 2 more points still after this one. The level at which you're going to connect, and then you need to think about how often it will be measured. That frequency was one of the columns that we had there. So if you're talking about quantities harvested, you probably do multiple harvests in a year. So you need to measure 1 for each agricultural season. If you're talking about temperature and rainfall, these things can be measured daily. Are you gonna then take this daily measurement and take a yearly average, or a monthly average, or a weekly average? How does that connect to the rest of the data that you have? So based on this, you'll be able to make a list of all the different levels of observation and time periods that appear in your data. And those are the things that you will list in your data linkage table. And then finally, you loop this back together into how you will actually connect one of these to the next. And so this was just the list of all the data sets, and you have kind of a broad plan on how to connect them. And then you have a data flow chart, which is basically a plan of how to actually connect them step by step. You, as field coordinators, do not need to worry as much about this. This is typically a guide for a research assistant's work. What you need to understand from this, and if you look, those of you who are close to this image will be able to see that at each different step of this flow chart, we are listing what is the unit of observation and what is the ID variable. So this is just to stress again that the way you collect the data and you identify individuals in the data will be important throughout a project's life cycle for data work. Okay, water break. Maria, I have 15 minutes still, is that correct? Okay, cool. Okay, so the next step of putting the research design into practice is making sure that the implementation of the project is compatible with the research design for the project. That means that usually when we are thinking about an intervention and designing a way to study that intervention, we have an ideal world in mind where we see, oh, this is going to happen at this time, and all these people were going to participate, and all these other people were not going to participate. But we know, I expect everyone here knows that things don't always go according to plan, and that plans can change, and that is fine. But what is important is that we're keeping track of what is happening in the field, and we're informing the principal investigators to make sure that any diversion from the original plan does not affect our research design. Or in other terms, that what we think we are studying is actually what we are studying. So that's all very abstract. So let's think about this in very practical terms of what are the different things that can happen during a project implementation that can affect study design. As in theory speech, we can think about violating the assumptions of our models. And there's usually 2 things that will change in the research design that can be affected. One is that we can have biased estimates. So I'm measuring something, but it's actually always going to be, the effect that I'm measuring is always going to be lower or higher than what is the actual effect. The other thing that can happen is that we can reduce power, which means that I do not have enough precision to know that this effect is actually a significant effect, even though it may be. Sorry, very abstract. Let's again talk about this in practice. One thing that can happen is contamination. This is when the control group is being treated, even though it's not meant to be treated. Can anyone give me an example of how this can happen? You can unmute and just,
Hi, I'm Janan. So I would say that if I am part of if I'm being treated and my spouse is not, but because we discuss of what I'm going through as being treated, so it's like contamination. That's what I will say.
That's almost contamination. That's actually what we call spillover,
Okay.
which is when someone is indirectly treated. Contamination would be when someone is directly treated. So let's say the intervention is to give someone medicine, and then this person is sharing their medicine with someone else. But they actually have the same effect. And in my original bullet point, they were together. But then I did some Googling. I was like, oh, interesting. This is the difference between the two. So basically what's happening here is that the effect that we're measuring is not only the effect of the treatment, right? We are confusing who is being treated, and therefore we have some bias. And we talked, and in the case that Jenna mentioned, this would be, for example, a positive spillover, where me being treated and talking to my colleague about what I have learned will maybe, if in a classroom setting, for example, or in agriculture setting, since I'm already there, I'm talking about the new techniques that I've learned, and therefore they may also be implementing them. And through this, their productivity will also increase. But it could be that we have negative spillovers. So, for example, if my neighbor is jealous that I have received some gifts or what they perceive as gifts that they have not received, and then that may have some negative welfare impact. Then we have, for example, take up, which is when not all individuals in the treatment group are actually treated, even though they are eligible to be treated. So they're offered treatment and they don't actually take up. Have any of you come across a situation like this in your projects, where you've seen something like this? Yes? Do you want to tell me? You don't have to, but I would like to hear about it.
Well, this is fun. I mean, nothing crazy, just internet. We're helping the WFP with a smartphone application, and so internet capacity is not always 100%, especially in more rural areas. And so even though people might have access to smartphones and access to the application and access to all of the things they might need, the internet connectivity to use the application itself is not efficient. And so, you can train them as many times as you want to, but at the end of the day, if you have to travel to another village to use the internet to do this thing, sometimes I just might not want to do that every day. So we're seeing a bit of that in our project.
Yeah, that's a great example. So although they have access to the treatment, they're actually not using it, right? And then finally, we have another example, which is attrition. That's when we lose people over different observations in time. So we go to a baseline and we collect data, and then we go back for a midline or an endline, and we don't find the same people again. So all of these things are common things, and they will affect our study in different ways. So, for example, low take up, and high attrition will reduce the precision in our estimate, so it will have a problem with power. And there are methods to address all of these different things. And this can be done. It can be incorporated into the study design, but for us to be able to do that, we need to know that these things are happening. So what's important here is to make sure that we know in real time what is happening in the field so that we can inform and adapt our research design if needed. And as field coordinators, you will be the biggest source of information about what's going on in the field. And it's really important to pass this information on so that we can maintain the rigorosity of the research. A few more notes on this. So in all projects, the timing and location of delivery are important. So knowing when the implementation is happening and where and who is actually getting access to the project is very important. And collecting information in real time is ideal so that we do not lose track of any information. If we're monitoring things often, if we're monitoring every week, then we know that 1 week the road was not there and now it is there. If we're only monitoring every 4 weeks, then I don't know exactly in which time of that period that happened. And that's just a general example. It will depend on your project. And this is particularly important for cost data when you're doing cost-benefit analysis, because prices can be volatile, and we want to be keeping track of this. And again, this is the kind of information that only someone who's very close to the field and to the implementation will have access to. And that's all fine when real-time data is available, and sometimes it's not. Sometimes we're trying to get historical data, and then we need to understand exactly what that historical data is saying. So interacting with the people who were there for project implementation and who have that knowledge and who understand the data that we are getting about historical events or recently past events is key. And again, building these relationships with these people is something that only someone that is in the field and is close to implementers can do. And then the last thing I want to talk to you about is randomization. Randomization, when we talk about methods for evaluating impact, randomized control trials are always one of the first to come to mind, and randomization is key here. And basically, randomization plays a role in making sure that people and samples or the data that we're collecting is comparable. And there's a bit of confusion because there are actually two random processes that we typically implement as part of our study. So one is random sampling. That's when we're randomly selecting a sample of our population of interest to survey. And basically what we are trying to do is to, through this random sampling, create a sample that is representative of the population. And then we have randomized treatment assignments, which is the process of randomly assigning eligible units to either treatment or control. And what we are trying to do with this is to make sure that treatment and control arms are comparable through this random process. And what is really important for the credibility of our studies and to make sure that, you know, the results that we are creating will have maximum impact and outreach, is that any random process needs to be fair and transparent, and people should be able to scrutinize it. Maria has already talked about this more generally in terms of data and research, but that's how this applies specifically to random processes, is that in general, we want to make sure that these random processes are implemented through code. And the reason why we want to do that is that code makes it transparent and easy enough to obtain exactly the same result again. So if someone is like, oh no, I don't know that what you did was actually random, and I don't know that this is actually the output of a random process, then they can go again and do it again and obtain exactly the same outcome that you have implemented before. So it's the gold standard for verifiability, if that word exists. I'm making a lot of words up today. Writing code is a necessary but not a sufficient condition for random processes to be reproducible, or meaning that they can be done again and again and obtain the same result. And you will see in the R and Stata Labs, hopefully, how to do this. And there's a few steps that you need to follow in code to make sure that that is the case. But that's also a reason, for example, why we recommend that people do randomizations in Stata or R and then preload the treatment assignment or sampling assignment to Survey CTO instead of doing this on the go as part of a survey form. However, this is the ideal world, and we all work in non-ideal worlds, and we know that sometimes it's not possible to use code, and that we need to do randomizations in the field as we go. And what's important here is that we make sure to document this process and to have very clear protocols on every step of this randomization, so that it's easy to communicate what is happening, and also to understand what are the shortcomings of this. So there's a lot of different statistical procedures that cannot be implemented if we're doing a field randomization. But what's important is to make sure that we can communicate the certainty that there was no tampering in the outcomes that we're observing. So there are all sorts of things. I think Burke Osler has a cool video where he shows like actually he recorded the randomization process and then puts it available on the project's website. There's a lot of different strategies, but for now all you should know is that if this is your case, then discuss how you can make this process clear and transparent, even if you're not using code. So just to sum up, as field coordinators, when it comes to translating research design into a measurement framework, there are 4 key responsibilities that you have. The first one is to understand the research design and how it translates into the data structure. And the best way to do that is to study the data map and make sure that you have a data map and that you have discussed it with your team to understand it. Then it's your responsibility to ensure that the research design reflects the field reality, so that you're keeping the PIs informed of how the implementation is going, and that so they can make any adjustments if needed, ideally not needed. Then when it comes to acquiring data, making sure that that data has all the features that will be needed to transform it into analysis data. That's typically making sure that it's uniquely identified, but also making sure that we are measuring all the different outcomes and covariates that are important for our research design. And finally, when there is some field randomization that needs to happen, think through these protocols and how to make it as credible as possible. There's a lot more content on this. This was just a 30-minute talk, but if you want to learn more, there's a lot of links to the wiki, to the development, research, and practice book.